To truly understand how digital systems work, we have to look past the screen and understand the language underneath. Binary. It's the foundation of everything in computing. We usually count in the decimal system where there are symbols from 0 to 9. Once a digit hits 9, it resets to 0 and its value carries over to the next digit. Say, for example, you have 321, which is actually 3 into 10 power 2 plus 2 into 10 power 1 plus 1 into 10 power 0. Since deci means 10, that's our base. Now, this isn't the only way. There's also another system called binary, where bi means 2. In this system, there is only two symbols, 1 and 0. Similarly, like in the decimal system, when a digit hits 1, it resets to 0 and its value carries over to the next digit. So let us figure out how to calculate the value of 10 in binary. So what we do is, since binary bi means 2, this will be the base for our system. So in 10, we multiply the second digit by 2 power 1 and we add that and multiply the first digit by 2 power 0, which comes out to be 2. This is how you convert a binary into decimal system. Now let's take another example. Let's convert 10101 from binary to decimal. So the first digit will have the place value 2 power 0, the second will have 2 power 1, 2 power 1, the third 2 power 2, 2 power 3, 2 power 4, and so on. So to convert this from your binary to decimal, all we have to do is multiply the corresponding face value with the corresponding place value and just sum it all. So your 1 into 2 power 4 plus 0 into 2 power 3 plus your 1 into 2 power 2 plus your 0 into 2 power 1 plus your 1 into 2 power 0. So at the end, it comes out to be your 2 power 4, which is 16, plus your 2 power 2, which is your 4. Okay, this becomes 0. Let me just rewrite that. This becomes your 4, plus this your 0, plus this is your 1. So we can sum it up. This comes out to be 21. So the value of 10101 from the binary system is actually 21 in the decimal system. Now let's do the reverse. Let's convert a decimal number into binary number. Now let's convert a number from the decimal system to binary system. So suppose we have a number, say 255. It's in the decimal system and we want to convert it to binary. Now how would we do this? Now there are two ways of approaching this. One is, if the number is small enough, you can approximate it, ballpark it, you can do it in your mind. But if the number is large, then you'll have to go for a more structured approach, and we'll be discussing that structured approach. So let's take the number 255. Let's just write it over here, 255, and we have to continuously divide it by 2 while keeping the remainder noted. So divide by 2, 1 and 2 and 7, remainder 1, so we noted over here. Similarly, do the same. So 6 and 3 and remainder noted as 1. Okay, similarly go ahead. Okay, 1, remainder noted as 1. Keep continuing the process. The mine denoted as 1, 2, 7, 1, 2. You go for 3 and 1. Lastly, 2, 1 and 1. So in this case, everything came out to be 1. But how do we read this? Do we go from top to bottom or bottom to top? So here, after we've reached 1, or we've reached the last either 0 or 1 in the final digit, what we do is that we read it from the bottom to top, not the top to bottom. We read it from the bottom to top. Okay, so at the end, your 255 from your decimal, okay, will be, okay, in your binary, it'll be 1 1 1 1 1 1 1 1. I know that sounds good to say. So 1 1 1 1 1 1 1 1. So your 255 is basically all your bits on. So that's 255. So 255 from the decimal system is 111 111 11 in your binary. So that's how we convert from decimal system to the binary system. Now, since we learned both the conversions, here's a few questions. So let's do 3 questions, and make sure you answer in the comment section. So convert 1024 from decimal to binary system. Second, convert 11010 from binary to decimal system. Convert 4098 from decimal to the binary system. So make sure to give your answers in the comment section, and we'll see you in the next video.